Hi, my name is Kuniaki Saito. I will introduce our work, COCO-FUNIT, Few-Shot Unsupervised Image Translation with a Content Conditioned Style Encoder. What is Few-Shot Unsupervised Image-to-Image Translation? One of the popular image translation is the translation between two domains. We can translate images between two domains that were given during training time. The popular examples are translation between horses and zebras or some animal faces. There are also image translation among more than two domains. We are given more than two domains in training phase and achieve the mapping from one domain to the other domains in the test phase. Stargan is one of the examples. Through shared latent space, their model can achieve translation among more than two domains. And their model can translate various attributes of human faces. The goal of few-shot image translation is generalization to unseen domains. The previous two examples are translation among domains that are given during training time. In few-shot image translation, we are given images from multiple training domains during training time, and in the test time, we are given a few images from unseen domain. Then the goal is to translate the content image into the image of unseen domains while maintaining the structure of the content. For example, given a content animal face image and a few style images from unseen animal categories, the goal of the task is to translate the content image into the image of unseen animals while maintaining the pose and location of face parts. To handle the style images from new domains, example-guided image translation method is often used, and FUNIT is one of the popular prior methods. Before going into the detail of our work, let's look at our results of few-shot image translation. Our proposed method achieves photorealistic few-shot image translation for challenging datasets, such as animal full-body images and bird images. While generating photorealistic images, our method preserves the input content information well. Let's go back to the prior work. The prior work basically tackled translation between well-aligned images. One example is animal face images. The image localizes the face, so the images are basically well-aligned. But in our research, we tackled more challenging datasets such as animal full-body images. Some images show whole body of animals, where some body parts are occluded in many images. Thus, the task is more challenging than a translation for animal face images. To tackle this task, we found that the prior example-guided image translation suffers from the content loss problem. The baseline method takes content and style image as input. When the pose of the object in the content image is not aligned well with that in the style image, the structure of the input content is not well preserved after the translation. For example, in the leftmost two columns, the body parts absent in the content image appear in translation results. In other examples, the pose of content is not well preserved, or the scale of body part is changed a lot by translation. The prior work tackled translation for well-aligned datasets, so the issue was not so significant. But for the challenging dataset, we need to handle this problem. We did an experiment to analyze this issue. For a given content and style image pair, we cropped the style image and input to translation networks. As shown in this result, though the cropped styles come from the same image, The output appearance varies a lot by the cropping. We compute the variance of style embedding for each crop and found that it varies a lot by the crops. With our new architecture, the embedding variance is suppressed and show consistent translation results for different crops. Why the embedding varies a lot with baseline method and how we overcome the issue. The prior work extracted content code and style code independently. Then the image is generated by adding the style code to content code. However, the style code is calculated without taking account for the content image, and we hypothesize that this is the cause of the content loss problem and propose a new architecture design. Our style code uses both the style code and content images. We aim to condition the style code on the input content image to make the style code consistent with content image. We called the content conditioned style encoder COCO. Let's look at the overview of COCO. First, since the style image may be missing some body part information present in the content image, we propose to concatenate a trainable bias parameter to complement information missing in the style image. Then we condition the style embedding with the embedding extracted from the content image to extract style information necessary for translation. Let's look at experimental results. We used 4 datasets to evaluate methods. For quantitative comparison, we conducted evaluation from 2 aspects: photorealism score and content preservation score. Photorealism score evaluates how well the translation results resemble style image distribution. Content preservation score measures how well the body part of input content is preserved. We could see the effectiveness of our method on both automatic metrics and human preference scores. Our architecture qualitatively shows better performance than the baseline method. While the baseline method doesn't produce realistic translation when the pose of content and style image are not well aligned, our architecture achieves photorealistic and content-preserving image translation. In addition, our method is effective for well-aligned images such as animal face translation. Our method can achieve challenging image translations such as dog to sheep or dog to deer image translation. Let's look at style interpolation results. We compute linearly interpolated style embedding between 2 style images from unseen domains. Given a content image and the interpolated style embedding, our model generates an image. We can see the transition between 2 style images. Our model can generate faithful results using these interpolated style codes. We can apply our model to video translation. Since we do not have any objective to ensure temporal consistency, some videos look a little blurry, but the results show the interesting and promising application of our method. Please visit our project page for more results and details of our method. Thanks for your attention.